So can I just check? Can you see my screen now? Can you see it saying question 5?
No.
Well, just give it a second. Hopefully it will come on in a sec.
Okay. Oh yeah, I can see it now.
Yeah, cool. Okay. So this is question 5. Okay. So I think you're pretty good on the opening bit. So obviously the thought process here is we haven't got any of the x's or the y's at the moment with the same number. They've all got different numbers. So the best thing to try and do here, it's going to be very hard to line the x's up with a 3 and a 5. But if we go and take equation number 1 and double it, we're going to get a 2y. Now, okay, the signs are different, but we'll worry about that in a minute. So we're going to choose to double equation number 1 in order that it gives us 2y. And the reason we're going to do that is because the other equation's got 2y. So we're going to double the first equation. So we're taking equation 1 and we're doubling everything. So we get 6x, doubling the 3x, plus 2y, and then doubling the 13, we get 26. So that row there is just doubling equation number 1. Now, if we then go and bring down equation number 2 underneath it, we've got the 5x minus 2y equaling 7. Now, it's probably this bit where you're getting a bit confused. What we've got here, whilst we've gone and got 2y and 2y, which is great, the signs are different. Now, because the signs are different, we've got to make the decision to add the two equations together, not to take away. All right. The way to get rid of the y's when the signs are different is to add the two equations together, not to take away. So if these had both been plus 2y plus 2y would have taken away. But the signs are different, so we add. It's not relevant that the x's have got the same sign, that they're both pluses. It doesn't matter. We're only trying to get rid of the y's, so they're the ones we focus on. So different sign, we add them together. So that's the big point. From then onwards, I think you'll be fine. 6x plus 5x is 11x. 26 add 7 is 33. So 11 watts are 33, 11 threes are 33, so x must be 3. We then go back and take either of the equations. So this step 2 is just the same as always. So let's say we go back to the first equation, 3x plus y equals 13. We've just worked out that x is 3, so we bring the 3 up here. 3 times x is 3 times 3, which is 9. 9 plus y must be 13, so therefore y must be 4. Does that kind of make sense?
Yeah.
Okay, let's just do question 7, just so you see another similar one.
Okay.
Okay, so with question 7, all right, so our thought process, we could actually, if we wanted to, we could times by 11 to line the x's up. That would be absolutely fine. But I've decided to times by 4 to line the y's up, okay? Because that would give me a 4y. I've got a 4y here. So I'm going to take equation number 1 and multiply everything by 4. So 4 lots of that, 4 lots of that, 4 lots of that. I get 4x plus 4y equaling 28. I then bring down equation number 2 underneath it. And just like the previous one, what I've now got is a plus 4y and a minus 4y. Because the signs are different, I have to choose to add the equations together. So 4x plus 11x is 15x. 28 plus 2 is 30. 15x equals 30. So therefore x must be 2, because 2 lots of 15 are 30. Go back and take either of the equations. Makes sense to take the easy one. I've just worked out that x is 2. So bring the 2 up here. 2 add y is 7. So y must be 5.
Okay.
Any bits of that you want me to go over, or do you want me just to leave it with you?
I think that's pretty good. Could you just go over the last bit of y in question 7?
Absolutely. Yeah, absolutely. I'll go over the purple bit again.
Yeah.
So we got halfway there, Tess, when we've got the x equaling 2. All right, we've worked out one of the two variables. We've worked out x. What we've now got to do is work out y.
Yeah.
So to do that, we go back and start again. So we go back to either of the equations that we started with. Okay, doesn't matter which one you choose to work with, but it makes sense to go for the easier one. So I'm
Yeah.
working with x plus y equals 7. I've taken that and I've brought it over here. Now, x plus y equals 7, but I've just worked out that x equals 2. So this is 2. X is 2. So if x is 2, y must be the bit left over to give me 7. So y's got to be 5.
Okay.
Yeah?
Yeah, thank you.
Yeah, no worries, Tess. Well, keep it up. It was a super bit of work you did the last piece, so I'll leave you to it.
Okay.
Okay, cheers. Bye.